In this lecture, we discuss the new chapter, that is the partial differential equations. What is the partial differential equations? So before that, we study what is a differential equation. So simple differential equation. So let y is equal to fx be a function. Y is equal to fx be a function. So there are two variables x and y, where y is a dependent variable and x is an independent variable. Then we obtain some differential equation. So that is simple differential equation, where dy by dx is the differential coefficient. If z is equal to f of xy, z is equal to f of xy is the function here. So in this function, there are two independent variables, x and y. Z is a dependent variable. So what is the equation, differential equation? So there are partial derivatives, dou z by dou x or dou z by dou y. So there are partial derivatives, dou z by dou x and dou z by dou y. And higher derivatives are also there. So here, this implies simple derivative dy by dx. So this is a differential coefficient. So an equation containing only dy by dx, then the equation is called simple differential equation. An equation containing such type of differential coefficients, then the differential equation is called partial differential equation. So what is the difference between simple differential equation and partial differential equation? So this differential arises here. So partial differential equation, when the independent variables are more than one, then we get a partial differential equation. So definition is very simple. So what is the order of the partial differential equation? So order of the partial differential equation is the order of highest order partial derivative occur in the partial differential equation. Okay. The order of partial differential equation is the order of highest order partial derivative occurring in the partial differential equation. Then it is called order of the partial differential equation. So similarly, what is the degree of the partial differential equation? So degree of the partial differential equation is the greatest exponent of the highest order partial derivative occurring in the partial differential equation is called degree of the partial differential equation. So we understand what is the order and degree of the partial differential equation by giving an example. So for example, 1. So let us take an example, x dou z by dou x plus y dou z by dou y is equal to 0. So this is a differential equation. So what is the order of this differential equation? And what is the degree of this differential equation? So here what happened? So first order differential coefficient, partial differential coefficient occurs. So that is dou z by dou x and dou z by dou y. So this is the first order and first degree. Degree is also first degree here. So the exponent, partial derivative exponent occurs here, that is degree 1. First order and first degree. Partial differential equation. So we take another example. So that is something dou 2zy dou x square plus something x dou z by dou x is equal to 0. So what is this? So this differential equation, partial differential equation, is of order 2. So this is the second order differential coefficient. So this is second order and first degree partial differential equation and first degree. Okay. So we take another example. So this is the dou z by dou x bracket square plus dou 2z by dou x square is equal to 0. So what is the order and degree of this differential equation? So order of this differential equation is 2. So what is the highest order differential coefficient? So dou 2z by dou x square. So this is the second order. And so what is the degree of this differential equation? So degree of this differential equation is 1 and first degree. So this is not a degree because this is not higher order differential coefficient. So 2 is not degree of the differential equation. So degree of this differential equation is 1 here. So this is second order and first degree partial differential equation. Okay. So it is very simple to understand by using an example. So what is the degree and order of the differential equations? Okay. So what is the formation of how to form the partial differential equation? Okay. So there are two types there. To obtain the partial differential equation by elimination of arbitrary constants and by elimination of arbitrary functions. Before that, so classification of first order partial differential equation. What is the classification? Of first order PDE. So that is the partial differential equation. Okay. So we adopt here some standard notations. We adopt some standard notations as follows. So what is the dou z by dou x? So this is the first order partial derivative. So that is dou z by dou x is denoted by p here. Okay. So we giving some standard notation. So we denote dou z by dou x by simply p. So what is the dou z by dou y? Dou z by dou y is equal to q. Then what is the dou 2z by dou x dou y? Or something dou 2z y or dou x square is equal to r. Okay, so what is the dou 2z y? Dou x dou y is equal to s. And what is the dou 2z y dou y square is equal to p. So we taking such notations here. So what is the dou z by dou x denoted by p, dou z by dou y denoted by q, dou z by dou r is equal to r, dou 2z by dou x dou y is equal to x, and dou 2z by dou y square is equal to t. Okay. So in general we write the partial in general we write the partial differential equation in the form f of x, y, z, p, q is equal to 0. Okay. So there are three variables. X, Y, Z are three variables. We don't know what is the dependent variable and what are the independent variables. P is the dou z by dou x and Q is dou z by dou y. So we generally denote the partial differential equation in this form here. F of x, y, z, p, q, 0. So how to obtain this partial differential equation? So formation of partial differential equation. Okay. So how to obtain the partial differential equation? So there are two types. Let us consider there are two types to obtaining partial differential equation. So type 1 is 1. So by elimination of arbitrary constant. By elimination of arbitrary constant. And what is the second method to obtain the partial differential equation is, so that is the second is by elimination of arbitrary function. By elimination of arbitrary function. Okay. So how to obtain the partial differential equation? So there are two methods to finding the partial differential equation. The first is elimination by arbitrary constant and second is elimination by arbitrary functions. So we now discuss. So what is the first method? By elimination of arbitrary constant. Okay. So let us take the method here by elimination of arbitrary function. Okay, so this is the method here. We discuss this method. Okay, arbitrary constants. First, arbitrary constants. Okay. Let us consider the function. Let us consider the function f of x, y, z, p, q. F of x, y, z, p, q is equal to 0, where a and b are arbitrary constant. Where a and b are arbitrary constant. So we consider the function f of x, y, z, p, q is equal to 0. So p is a dou z by dou x, q is a dou z by dou y, and this is equal to 0. So this is the function here. Where a and b, just what happened here, right? A, B. So this is a primitive. So this is a function in x, y, z with arbitrary constant a and b. This is a function. So we obtain the partial differential equation by using this function. Okay? By limiting a and b, arbitrary constant. So this is a primitive. So this is function is given here. So what is our target? To obtain the partial differential equation by using that function. So differentiating equation 1 with respect to x and y we get. With respect to x and y we get. Okay, so this is the function given here. So we differentiate equation 1 with respect to x and y we get. So derivative of this is the dou f by dou x plus differentiate, we consider that z is a dependent variable and x and y are independent variable. Z depends on x and y. So we obtain the partial derivative of this with respect to x. So what is the dou f by dou x? Keeping y constant. But z is not constant, z is a dependent variable. Plus dou f by dou z. So differentiate this with respect to s. So that is dou f by dou z into dou z by dou x is equal to 0. Again we differentiate this partial differential equation with respect to y. So that is dou f by dou y, keeping x constant temporarily, keeping x constant. So that is dou f by dou y plus, but z is not a independent variable. Z depends on x and y. So what is the derivative of this? So that is derivative of this. So that is dou f by dou y plus dou f by dou z into dou z by dou y is equal to 0. So we use here standard notation. So those equation can be written in the form here dou f by dou x plus dou f by dou z into p. So dou z by dou x is p is equal to 0. And dou f by dou y plus dou f by dou z into q is equal to 0. So this is equation 2. So this is so we get after differentiating this equation with respect to x and y. So we eliminate. So we eliminate arbitrary constants a and b, a and b from equations 1 and 2. So this is equation number 1 and this is equation number 2. By using those two equations, we eliminate the arbitrary constant a and b. We get the required partial differential equation. So this is the formation of partial differential equation by eliminating arbitrary constant. So how to obtain? So we take, so that is this equation in the form here. So that is f of something f of x, y, z, p, q is equal to 0. So we get the equation partial differential equation. So this is general form. So f of x, y, z, p, q is equal to 0 here. So after eliminating a and b from those two equations, we get this equation. Okay. So we now obtain the partial differential equation by taking example. So take an example. Okay. Example. Eliminate the arbitrary constants from x square plus y square plus z minus a bracket square is equal to b square. Eliminate the arbitrary constant from this equation where a and b are arbitrary constant and obtain the partial differential equation here. Okay, partial differential equation. So there are three variables x, y, z. So we consider z is the dependent variable and x and y are the independent variable, and a and b are the arbitrary constants. So what is the solution? Differentiate it partially with respect to x and y. We get, so what is the partial derivative of this with respect to x? So what happened here? So derivative of this with respect to x, so that is 2x. What is the derivative of y square? So with respect, we taking a partial derivative with respect to x, keeping y is a constant, so derivative is 0. Plus, what happened here? So that is derivative of this 2 times z minus a into dou z by dou x is equal to b square. So this is arbitrary constant. So what is the derivative of this? Is 0. Okay. So we now use the notation here. So that is the 2 to get cancelled. So this can be written as x plus z minus a into dou z by dou x is p is equal to 0. Okay. So this is equation number 1 here. 1. So again we differentiate this partially with respect to y, keeping x constant. So derivative of x is 0. So what is the derivative of 2y? Y square, that is 2y. plus what is the derivative of this? 2 into z minus a. So into derivative of z with respect to y, dou z by dou y is equal to 0, implies that. So 2 to get cancels, so that is y plus z minus a. What is the dou z by dou y is q is equal to 0. So that is equation number 2 here. So eliminating a and b from equation 1 and 2, we get eliminate. Arbitrary constant. So what is the method here? To eliminate arbitrary constant a and b, we get the required partial differential equation. Eliminate a and b from 1 and 2. Or you can use this equation also. So it depends on the example here. So eliminate a and b from equation 1 and 2, we get. So what is the from equation 1 implies that here? So what is z minus a? Already b is eliminated here. Only a is remaining there. So we also eliminate a. b is already eliminated. So we eliminate a. So here from equation 1, z minus a can be written as. What happened? Z minus a can be written as. So this is z minus a is equal to z minus a is equal to minus x divided by p. Okay, so z minus a is equal to minus x upon p. So putting this value in this equation, putting this in equation 2. What happened here? So y plus, what is z minus a? Y minus x upon p into q is equal to 0. So then what happened here? So this is what happened? So this is yp minus xq is equal to 0. So this is the required partial differential equation by eliminating arbitrary constant a and b. So this is the required partial differential equation. So example is very simple here. Okay. So we take another example. Eliminate the arbitrary constants a and b. Next example. Arbitrary constant a and b from the equation. So that is x minus a bracket square plus y minus b bracket square plus z square is equal to 4. So this is the equation given here. So obtain the partial differential equation by eliminating a and b from this equation. Okay, solution. Differentiate it with respect to x and y. We get. So what is the derivative of this with respect to x? So then what happens? So that is the derivative of this is with respect to x, keeping y constant. But z is not constant because z is a dependent variable. Z is a function of x and y. So differentiate this with respect to x partially. So that is 2 into x minus a plus. What is the derivative of this? So derivative of this is 0 because y is a constant, b is arbitrary constant. So derivative of this is 0. So what is this? So that is 2z into dou z by dou x is equal to derivative of 4 is 0. So by putting the notation here, so we get here 2 get cancelled. So x minus a plus zp is equal to 0 here. Okay. So again, we differentiate this equation with respect to y. We get with respect to y partially, keeping x constant. So this is a constant, derivative of this is 0. Then what happened? 2 into y minus b plus 2z, derivative of this with respect to y, 2z into dou z by dou y is equal to 0. So this can be written as 2 to get cancelled. So that is y minus b plus z into q is equal to 0. So these are the equations here. So this is equation 1, this is equation 2. So how to eliminate the arbitrary constant a and b from those equations? Also you use this equation. So what happened here? Putting what is x minus a is equal to zp minus zp. What is y minus b is equal to minus zq in this equation. In given equation. So what happened here? So what is x minus a? So that is minus zp means z square p square. Plus what is y minus b? So that is z square q square. Plus z square as it is equal to 4 here. So what happened? So this is z square into p square plus q square plus 1 is equal to 4. So this is very simple. First we differentiate this equation partially with respect to x and y. With respect to x we get this equation. With respect to y we get this equation. Then eliminate a and b. That is necessary to eliminate the arbitrary constant a and b. So we get partial differential equation. So we write here x minus a is equal to minus zp, y minus b is equal to minus zq. Putting this value in this equation and we eliminate the arbitrary constant a and b and we get the required partial differential equation. So this is the partial differential equation. So okay. So we also take another example. Let's take. Eliminate the arbitrary constants from z is equal to a into bracket x plus y. There is only one arbitrary constant, a. Okay. So what is the solution? Let z is equal to a into bracket x plus y is the given differential equation. Okay. Sorry, is the equation simple equation. So we obtain the partial differential equation. So differentiate partially with respect to x and y we get. With respect to x and y we get. So what happens? So what is the derivative of this? With respect to x, so that is dou z by dou x. With respect to x, keeping y constant. So what is the derivative of this? Derivative of a as it is. What is the derivative of x with respect to x? 1. What is the derivative of y? 0. So a into 1, so that is a. So this implies that p is equal to a. P is equal to a. So then what happened? And differentiate this partially with respect to y. So what is the dou z by dou y? Is equal to a as it is. So then what is the derivative of this with respect to y, keeping x constant? So this is derivative 0, y derivative that is 1. So this implies that q is equal to a. Then what happens? So how to write this equation? By eliminating an arbitrary constant. Constant a, arbitrary constant a we have. So what is this? So put, what happened here? So put p is equal to a is equal to p here. So that is z is equal to a is equal to p into bracket x plus y. But a is also q there. So put a is equal to q there. So that is z is equal to q into bracket x plus y. So we get there are two partial differential equations. So this is also partial differential. This is also partial differential. Why? So why we get the two partial differential equation? So as the number of arbitrary constant as the number of arbitrary constant is 1 is less than, there is only one arbitrary constant, that is A, is less than the number of independent variable that is 2, since in partial derivative at least there are two independent variables, so you can take at least two variables, so we take 2 here. So hence we obtain two partial differential equations. Two partial differential equations. Okay. So here only one arbitrary constant is there, and this is less than the number of independent variables. Because in partial differential equation there must be at least two independent variables. So we get here two partial differential equation of this differential equation. Okay. So tomorrow we take example by eliminating arbitrary functions. Okay. So this is the formation of partial differential equation. So we stop here. Thank you.